All right, so we are gonna, because it's a short day, we're gonna teach the whole time, and then I will be available Friday morning at 7 for those procrastinators of you that do need a little help at the end. So yeah, we'll just see what happens. All right, so it is 11:18 today. This is third period, and this is Chem. 11:10, chapter 5, review. Okay, we're going to start off by balancing an equation. Raise your handy, and let's go for 10 hands. So I got H3, BO3, breaks down to H4, B6, O11, plus H2O. Balance that sucker, and I want 10 hands. One, two, three, 4, 5, 6, 4 more, 7, 'Am I going to get 3 more? Eight, dos más. Negative? Well, we got to get going. So who is 4? What do you got, Hodge?
Wait, I thought I saw it.
That's fine. Go for it, Hodgkiss. What do you got?
I think I got 6, 1, and 7.
6, 1, and 7. You think, or that's what you have written down? That's what you got. You just don't know if you're right.
Yeah.
Anybody back him up? Yeah, just like that. Where'd you start?
I started in the middle.
Start in the middle, like right here?
Well, that one, started on the middle one.
The middle one, right here?
Most complicated, yeah.
Yeah, most complicated. Right. That's what I would have done. And I would have literally said, look, there's a B there and a B there, right? I got 6 there. I've got to have 6 there. And then from there, did everything else. Does that make sense? That's what I would have done. Okay? How about this one? We're going to go 10. Hopefully get 10 again. Or finally get 10. That's an S, not an 8. H2S. Balance that sucker. While you're balancing that, I'm going to get going here. Okay, again, I need 10 hands to balance that equation. One. Two, three. Compare with her. Four. Oh, Schumann. Nope. Is that a can? Aluminum goes right here in this big bag, or this big container over here with the bag in it. Five. The one with the big garbage bag in it. Thank you. 6, 7. 3 more. I need 3 more. Am I not going to get 3 more? We just need to go on. Eight. 2 more. Negative. All right, we got to get rolling. We're going to run out of time. Who is 5? Right there, Stuart. What do you got?
18144.
18144. Anybody else back that up? Just like that, Ken. You got that? All righty. Now, here is the next question. Given 29.6 grams of HI and 45.4 grams of H2SO4, how many moles of H2O will be produced? Who can tell me what kind of question this is? Anybody? Why would you say limiting reactant? 2? When it gives you 2 things, especially 2 reactants, it's a limiting reactant. Now, can anybody else tell me what I've done here that makes this a little easier, though, than some of the ones we did? I'm in grams, okay, but that's not what makes it easier. I'm asking for moles instead of having you go all the way back to grams. So what did I do, Perks? I took out a step. I took out that last step of going back, right? So we're going to do this basically twice. I'm going to go 29.6 grams of HI. I'm going to times that by what? What's going to go here? Where am I going to go first almost every time? Going to molar mass, right? So what's going to go in my numerator?
1 mole.
1 mole of HI for every what? Have I mentioned that we should all have a calculator in our periodic table out already? So we can do all this math? What do you got? 127.912 grams of HI. Okay. Now I'm in moles. Where do I go next?
With the mole to mole ratio.
Mole to mole ratio, or sometimes they call it the, what else do we call it besides the mole ratio, or the mole to mole? It is the, I wrote this down, the molar ratio. Mole to mole or molar ratio. And what do I get here? Nobody knows my mole to mole for this?
4 moles of H2O.
4 moles of H2O for every
8 moles of
8 moles of HI, right? Now going back to what Perks told me, we're done. Because I asked you for it in moles. So my moles of HI reduce out, my grams of HI reduce out, I'm going to be left in moles of H2O, and the answer is what?
moles of H2O.
Anybody back Stenger up on that? Yeah? Okay. That's one answer. Now what am I going to do?
Find the same for the H2SO4.
And I'm going to be doing pretty much the same thing, aren't I? So I'm going to start with 45.4 grams of H2SO4. I'm going to times that by what?
1 mole of H2SO4.
1 mole of H2SO4 for every... Anybody got this molar mass yet? Grams of H2SO4, right? Then I'm going to go to my, what's this called?
Molar ratio.
Molar ratio or mole to mole ratio, and it is what for this one?
4H2O.
4 moles of H2O over
1 mole of H2O.
1 mole of H2SO4, and my moles of H2SO4 reduce out, my grams of H2SO4 reduce out, and I end up with what? Anybody back her up? Yeah? Okay. So here's my question. What's the answer? The smaller one, right? So it's this. That is my answer. That's how many moles are going to be produced. Then it's going to ask me what? Which one is the limiting reactant? And the limiting reactant is the one that did what? That got me to there, right? So that's going to be my HI is my limiting reactant. Okay? So from there, now let's say I wrote this. Suppose in the lab you produced 0.110 moles of H2O. Okay? What is the percent yield? Okay, who remembers how to do that?
94.8%.
Okay, but how do I do that?
Oh, yeah, so you do 0.110 divided by 0.116,
And you got what?
and then times it by 100.
Then times it by 100, and what'd you get?
94.8%.
94.8%. Did anybody else get 94.8%? Okay, now how do I know which goes where here? What is percent yield? Anybody remember?
Actual over theoretical.
Actual over theoretical, right? And where do those numbers come from? Actual comes from the what? The lab. The theoretical comes from the math, remember? Okay? Now, understand this. If I asked you this question, why do we bother to go to moles, which is pretty much the first step in every equation, instead of just using grams? I mean, when we're in the lab, we put everything on a balance, right? So we have the gram value. Why do we do it in moles every time then, instead of just using those values with grams? Anybody know? Anybody remember something I've said that should answer this question? Nobody? Well, go back to your balanced equation, and I've said something about these before. That 6, that 1, and that 7 are only in two values. Moles or, what was the other one I said? Molecules. Moles or molecules. It is never, ever, ever, ever in grams. That's why we have to go to moles, is because equations aren't written in grams. They're written in moles, and they're written in molecules, and that is it. Which is why your first step most of the time is to convert to moles. Okay? Alrighty, now from there, we're going to go, okay, now, they do the, well, let me cover this real quick. From the beginning of this problem to the end of this problem are 12 questions on the test. Okay? If you add up the balancing equations, the stoichiometric, and the percent yield, there are 12 of those on the test. If you were able to do that, you should get all 12 of those right. Okay? Now, obviously that's on the test, or I wouldn't bring it up. Now, they also do the exact same thing, but they ask it a different way. And let me show you what they do. Let's say I got 2x plus 3y is going to yield 4z. And then on the test, there are actual chemicals here, but it doesn't matter. Okay? And they make this table that looks like this. Okay? And they have this. Okay? And then this is initial. And this is like after, 2 minutes or something. Whatever happens. So let's say initially, I dump 10 of those in and 10 of those in. Now when I'm saying 10, I'm talking about 10 moles or 10 what? Molecules. It could be either one. It doesn't matter. Initially, how much? So this is my X, this is my Y, this is my Z. How much Z do I have when I start this reaction? As soon as I dump them in there, how much Z do I have?
0.
I don't have any, right? Now, after 2 minutes, some of this reacts, right? So let's say that after 2 minutes, I've used 4 of these, and I've used 6 of those. Okay? How much Z am I going to have now if I've used 4 of that, and I've used 6 of that?
8.
How did I get 8, Stuart?
Because you doubled it.
Yeah, I just looked at my balanced equation and goes, well, if I use 2 of this, I'm going to get 4 of that, right? But this tells me I'm using 4 of that, so I'm going to make that an 8, right? What if I would have made that a 4? What if this was now a 4? What's that got to be? What if I made that a 5? What is this going to be?
10,
10. Why'd you get 10?
since you're doubling it.
I'm doubling it? Oh, I doubled that way. Yeah, okay. I would have done this. I would have said, well, 5 is 2.5 times of 2, right? 10's 2.5 times of 4, right? What would this have been?
7.5.
7.5? Do you see what I'm saying? And they ask you 2 of these. And it's just because they're trying to get you to just do this math in your head and doing all those conversions. You know what I'm saying? So you ought to be able to just look at these. Look at the equation. Look at the ratios. Fill this in. Does that make sense? Okay? And they actually look for this number right here. I think everything's filled in and they're just looking for that. Okay? Alrighty, now, if you would have done the homework, this question would make so much more sense right now. Okay? But I'm going to assume that some of you are those 77. So this is what we've got. We've got 2 big circles here. I'm going to go A plus 3B yields A B3. Okay? So let's say they're my 2. That's my drawing, right? And I'm going to produce this, okay? And I want to see what is going to be over here when this reaction's done, okay? Now, how many A's are in my drawing? Anybody count them? 9. How many B's are in my drawing? Just so we can get that out of there.
18.
18. Okay. So, if I'm going to base it on this reaction, how many products can I make based upon this situation? And they're my numbers.
9.
9? I can make 9 of these. So he's saying I can use all 9 of them up, right? Okay, so based upon this reaction, if I'm going to use 9 A's, how many B's do I need? I need 27, don't I? But I only have 18, so can I use 9 of those? No, I can actually only use 6. Why only 6, Perks? Because I have to put 3 B's with every 1 A. And after I've used 6 A's, I'm going to be all out of B's, right? So I come over here and I'm going to use 6 A's. Each A is going to be surrounded by 3 B's, right? Correct? What else is going to be in my beaker? I've got that.
Excess A.
Excess A. So now I'm going to have how many A's over here?
3.
3 A's. That's going to look something like that. That's what that artwork's going to look like. Now, there are 3 or 4 of these, but they're all under that same premise. Look at what's given, and just look at the ratios and say, okay, for every 1 of these, I need 3 of those. That's what it's going to look like. There is a question. Can anybody in here say they've started the homework? Does this look familiar? Wasn't there one almost identical to that? Well, there's like 3 almost identical to that on the test. Make sure you can understand and think through that, because that's what they're doing. They're just taking, they can have you do all the math. We've already done that, right? They're saying, can you look at this and logically piece them together just like we did right there? Does that make sense? Okay. So that's that. Now, from there, combustion. Okay, combustion. Combustion is always redox. Always. Does anybody know how to tell a combustion reaction? what a combustion reaction looks like? Okay, most of the combustion reactions we're going to do this year are all going to look the same. They're going to be a hydrocarbon plus O2, and it will always produce CO2 and H2O. Now, listen, this is what happens here, okay? I know that combustion is redox for a simple reason. Whenever they write O2, what's its number always going to be? 0. The minute it comes over here and bonds with either one of these, it's going to become a what? A 2 negative, right? Because that's what O is 99% of the time, right? Now, what's a hydrocarbon? Does anybody know what a hydrocarbon is?
Hydrogen bonded with a carbon.
It's a combination of hydrogen and carbons. That's it. On the homework, they did like C2H2, but they did it like this. Anybody know the question I'm talking about? It looks something like that, right? They're just trying to show you how it bonds. It doesn't matter. These two are the same thing, right? Now look. I know that O is a 0 and it goes to 2 negative, which tells me this is redox, right? What does that tell me about my oxygen?
It's being reduced.
It's being reduced. It is reduced, which makes it the what? Oxidizing agent. Why do you think they call it an oxidizing agent? Because it combines with oxygen. Oxygen will never be oxidized. Do you see what I'm saying? Oxygen is reduced, always. The reason they call it an oxidizer, do you see what they're trying to say there? So understand that oxygen will always be reduced. It is always going to be the oxidizing agent. The other thing, no matter what happens, has to be what then? It has to be oxidized, and it has to be my reducing agent. That's just always going to work that way. Okay? So, I wrote down this. I wrote down oxygen is never oxidized. Okay, and then I realized, I think there's one exception to that, so it's like 99.99% or something oxidized, or never oxidized, okay? So just understand that. Now, the law of conservation of mass. Does anybody know what else they write right here sometimes instead of mass? That is true, but that's not what we're talking about right now.
Matter?
Matter. Sometimes I'll write matter there. Matter, mass, the same thing. Okay? Now, did I already write this down? Why do we bother to convert 2 moles every time we do this? Is because an equation is only written in what? Moles or molecules, never in grams. Okay? Pay attention to that. All right, last thing we're going to do. Oh, no, 2 more things. We got to do redox first. Now, I fixed this in this class, right? 1 kg equals 2.2 pounds. We were the one that fixed that, right? I would also know that 1,000 grams is equal to 1 kilogram. Just some conversions for the test. Now, another redox half reactions, another equation that is on the test, or a question that's on the test that is direct from the homework, is this. Al solid plus Fe3 positive aqueous yields Fe solid plus Al3 positive aqueous. Anybody know the question I'm talking about? Okay, almost every kid that has done this question has missed it. Okay, did you miss it the first time? Do you know why you missed it the first time? No?
I haven't figured it out.
Did you miss it the first time? You got it right the first time. You must have read the whole question. Here's what every kid has done, except obviously these two. Everyone. I'll bet I've answered this question 7 times out of the 40% that did it. And that is this. The last sentence in the question says, include the states. Yeah, you see that look? I wish I could have filmed that look. You're like, yeah. It says include the states. Now look, what is going to happen? If I start with my Al solid, what is it going to produce? We did this yesterday, didn't we? Or last time? What's it going to give me?
Al3 positive aqueous, and it'll be plus 3 electrons.
Right? Now, electrons don't ever have a state on them. Where are those electrons going to end up? Don't they have to now go on the other side? So I'm going to go what? What's my next one going to say?
Plus 3 electrons yields Fe solid.
I believe there's 2 of those on the test. Just like that. I mean, just like that. Now that makes perfect sense, doesn't it? Yeah. Yeah, I had a couple of kids. I mean, one kid emailed me last night, kind of pissed. Going, I've done this question. I know. I literally did it exactly the way you taught. And I go, yeah, that's a great job. I go, read the damn question. Because that's what happens. You get through the first 2 sentences and you're like, I know how to do this. So you hurry and do it, right? But you didn't read the whole question. And that happens on the test a lot. You're like, oh, yeah, I know how to do this. Answer the question. Is there like somebody over there? Can I help you?
Yeah, the back piece.
Oh, shit.
Do you want me to come back in a little bit?
No, you're all right.
You sure?
Yeah, can I just write a question down so I can get them started?
For sure.
All righty. So I want everybody to do this, okay? How many molecules of sugar, that is C6, H12O6, are in 7.27 pounds of sugar? Okay.
I swear I can read them all the time.
you're all right.
I'm looking at this stage.
Okay, let's go.
This all gives me major throwbacks. This
Yeah.
material I just graduated with.
Uh-oh.
A
What
degree
is?
in biochemistry, so.
Oh, this should be like easy.
It is. I know I'm studying for the.
Okay, we're talking about the one day she was there.
Yep.
Literally the one day she was there. All right, so it's gonna be right there. So it's gotta be those 8.
Do you mind? Do you have your attendance? Let's check them real quick.
The other thing, so
Yep.
on the 2012.
Yep.
So she's already out.
Okay.
And then,
Okay.
all but, yeah, all but her
Let's get the rest of the
school.
Thank you.
Okay, yeah. I'm good though,
Okay.
myself. Okay. What are the odds? All right. Do I have anybody yet? Nobody? Okay, let's go for 5. We're a small class. Let's start with 5 and see what happens. 1. 2 and 3. Four. One more. So we can get through this before the bell rings. Did I put my 3x5 up here so you guys can see it?
No.
Don't let me forget to do that. Okay. Am I gonna get one more?
Does that say molecules or moles?
It says molecules. Do we all understand that this says molecules? Do you not have it?
No, because I haven't.
You stopped at moles?
Yeah.
Okay. Am I gonna get, is anybody close? Yeah? That still not even a very good molecules. My penmanship really sucks, doesn't it? Did you go to molecules? Did you go to molecules?
I think so.
Perks, did you go to molecules? You stopped at moles? Go to molecules real quick.
Stop the moles.
So now you're in molecules? Okay. Well, let's get going so we don't run out of time. So look, there's obviously a reason I keep harping on this, right? It means there's for sure one of these on the test, right? So I'm going to start with 7.27 pounds of C6H12O6, right? Well, where am I going to go first?
Convert it to kilograms.
I got to go to kilograms because I know I've got to end in grams before I can get to moles, right? So I'm going to go 1 kilogram is 2.2 pounds, right? Now, from kilograms, I'm going to go to grams, which I just wrote down. That's 1,000 grams for 1 kilogram, correct? Now I'm in grams. Now, most of you got to moles, which is going to be what?
1 mole over 180.156.
Did any of you spend the time to do this? Did all of you calculate this? Okay, now listen, people. You should remember this. Didn't we do this sugar the other day? You should have already had this value in your notes. See how that would have saved you some time? That's why I gave this one. See how I'm a thinker? Yeah. Now, that would put me into moles. But I asked for molecules. How do I go from moles to molecules?
Do Avogadro.
Avogadro's number, right? And that is 6.02 times 10 to the 23rd molecules for every 1 mole. Moles are gone, grams are gone, kilograms are gone, pounds are gone. What'd you get, Stenger?
I got 1.10 because of significant figures.
Okay.
Times 10 to the 25th.
Times 20 to the 25th molecules of C6H12. Now, why is that in molecules and not atoms?
Since it's not just an element.
Yeah, because sugar exists as a molecule and not an atom. Okay? I had one more, but actually, let's do this. Let me. I would highly recommend that you do this at home. Do this at home. Okay? How many grams are in 5.25 times 10 to the 25th atoms of sodium? Now, I do want to show you this. Here's my 3x5. Okay? There's the front of my 3x5. Wait a minute. And here is the back of my 3x5. Okay? I would highly recommend you do this problem at home. And if you have questions on it, I will be here Friday morning at 7 a.m. for any lingering questions. Okay, goodbye. Please do the homework. Study, prepare.